Hello students, welcome to chemistry class. Today we are going to study preparation of haloalkanes. We are going to prepare haloalkanes. The general formula for haloalkanes is Rx. Okay, so first method for preparation of haloalkanes is from alcohol. From alcohol. The general formula for alcohol is ROH. ROH is a general formula for alcohol. Here, when alcohol react with PCl5, phosphorus pentachloride, when alcohol react or heated with PCl5, it gives RCl. This OH is substituted by Cl. Then product form is RCl. Then minor product is POCl3, that is phosphoryl chloride, and HCl. Next method for the preparation of haloalkane is from PCl3. So alcohols when heated with PCl3, the product form is RCl and the byproduct is S3PO3, phosphorus acid. Okay, again alcohol when react with red phosphorus in presence of Yax halogen, that is chlorine, bromine, iodine. I'm taking here I2, then product form is Ri. Product form is Ri. And next method of preparation here from Lucas reagent. Lucas reagent is mixture of the mixture of conchyl and anhydrous ZnCl2. Then the product form is here RCl plus water. This process is also called Grove's process. Next method of preparation from alcohol, when alcohol react with sulfonyl chloride in presence of pyridine. Very important reactions. Then haloalkane is formed, that is RCl, and minor product is sulfur dioxide, which is in gaseous form, and also hydrochloric acid, which is also in gaseous form. Both are gases, both byproduct are gases. The best method for preparation, because both sulfur dioxide and hydrogen chloride is escape out, then purity of haloalkanes is more. This process is also called Darzen's process. So this is from alcohol. Okay, next method we prepare haloalkanes from alkene. Here I am taking the unsymmetrical alkene CH3CH double bond CH2. This is the unsymmetrical alkene and the name of this alkene is propene. When react with or treated with HBr. HBr is an unsymmetrical reagent. When unsymmetrical reagent react with unsymmetrical alkene, the product form is haloalkanes with the Markovnikov's rule. Here unsymmetrical reagent has a H plus and Br minus. So according to the Markovnikov's rule, H plus bonded with that double bonded carbon atom which contain higher number of hydrogen. So H plus bonded with this carbon. So product form is here CH3, here CH, Br and CH3. The name of this compound is 2-bromopropane. But if there is a presence of peroxide, organic peroxide, then it follows Antimarkovnikov's rule. This is Antimarkovnikov's rule. Antimarkovnikov's rule is also called kharsch effect. Kharsch effect or peroxide effect. This is also called peroxide effect. Then the positive part of the reagent bonded with that double bonded carbon atom which contain lower number of hydrogen. Then product form is CH3, CH2, CH2Br. The name of this compound is bromo, 1-bromo propane. 1-bromo propane. This is from alkene. So next method of preparation we are taking here, halide exchange method. Halide exchange method. Here I am taking RCl, chloroalkane. Chloroalkane when react with sodium iodide in presence of acetone. In presence of acetone, the product form is alkyl iodide or iodoalkane and NaCl. This is halide exchange method, and this reaction is also called Finkelstein reaction. Finkelstein reactions. So Finkelstein reactions is useful for the halide exchange method, and only iodoalkanes can be obtained by this method. We can use RBr here, and sodium iodide in presence of acetone. It gives Ri, iodoalkanes, and NaBr. So there is no formation of chloroalkane, bromoalkane, but we can use chloroalkane and bromoalkanes to prepare iodoalkanes by halide exchange method, which is called Finkelstein reaction. Another reactions here from alkane. When alkane like CH4 treated with Cl2 in presence of light, it gives haloalkanes, which further react with sunlight to give CH2Cl2, and which further give CH3 chloroform, and which further give carbon tetrachloride. So these are the important preparation of haloalkane.